right. Thank you, Dave. So when I first arrived at Georgia Tech, I was trying to figure out what my research project was going to be, and I had the opportunity to meet with Dave and with my current advisor, and what they both told me was, just so you're prepared, if you join this whole mobility thing, it's going to be a lot like drinking from a fire hose. And they were absolutely right, because the concept of mobility and the concept of transportation can mean so many different things. And so it's really exciting to be here because we get to try to explain a little bit about how we're making sense of it, and we also get to get some fantastic ideas from all of you. So without further ado, we'll tell you about our side of things. So first of all, at Tech, as part of our urban mobility focus, we have 5 major objectives. First, we're looking at identifying technical options. Most of us in the program are engineers, and so we want to find engineering solutions that we can apply to a bunch of different disciplines. As part of this process, we have 3 key steps. First of all, we want to assess the current impact and find out what it means in terms of sustainability and the triple bottom line. Once we do that, we can design our solutions, and a lot of these solutions that we're working with revolve around information technology and really how you can use that information to maximize the impact of existing resources. It's a lot of what Alan just talked about is very similar to what we're doing, and we're trying to figure out, okay, he's presented this awesome vision, and so how do you actually get down to the nuts and bolts of implementing something like that? And finally, we want to pilot these solutions that we come up with, and right now we're working with the City of Atlanta and regions around Tech to not only test them out and improve them, but also to try to make positive impacts on the surrounding area. So collectively, this creates our research thrust on sustainable mobility, and it's been great so far, and it's something that we're trying to keep the momentum up with and continue to expand. So to go back to that initial objective, assessing impact, the first step is really, how do you figure out what's important, and what does sustainability really even mean when you're talking about a system that's as complex as a transportation network or infrastructure? Because when you break something like that down, it's made of countless other systems, and by the time you work down to the smaller pieces, you have thousands of different variables, and sometimes it's really hard to figure out what is really making a difference. And so a lot of what we've been doing and what I do personally at Tech is we're working with modeling techniques so that we can really identify what these important factors are. The picture that you're looking at right here is just a small slice of a model that we've been working with. It's part of a language called SysML, which is Systems Modeling Language, and it's a way to formalize some of these techniques and to help automate the process, automate the calculations, and things of that nature. So just to give you an idea of the power that's behind this, I'll show you one example from our results, and that's the link between sort of where you obtain your energy and what that means in terms of transportation. So what you're looking at on this slide, on the left there, or your left, you have a breakdown of power generation in Georgia. In this context, power, we're talking about electricity. And as you can see, in our state, it's pretty much dominated by coal. We have a lot of coal-fired power plants. And on the right is some of our modeling results, and this is CO2 output by various modes of transportation within the Atlanta area. So you have standard vehicles on the left there, gasoline automobiles, diesel automobiles, hybrids, plug-in hybrids, and fully electric. And then on the right, you have the 2 most common forms of public transportation, bus and rail. And what jumps out at you from this graph is that your primary alternative fuel platforms, in this case the electric vehicles, are actually some of the worst ways to get around the city in terms of greenhouse gas emissions, and there's also a correlation with overall energy use as well. And so this really surprised us, and we decided it was something we wanted to look into, and the modeling lets us do that. So one thing we did was we said, what would happen if we were getting our electricity from a cleaner source? And so we ran the same model, but now we're using electricity generations from a state such as Washington. Washington's pretty clean. They get almost 70% of their power from hydroelectric generation. And as you can see, if I just flip back and forth between those two graphs, there's an immediate huge difference. And so the point that we kind of obtained from all of this is sometimes you have to look beyond the current green buzz or policy issue of the moment. For example, the current federal administration is really pushing this huge movement to hybrids and electric vehicles, but you have to look at the individual situation, because if we convert everything to electric in Atlanta, it's really not going to help that much until we address some other issues. And so our work really enables us to break that down and consider regional differences. And I think it has the potential for a lot of impact. So the final part of our assessment objective is all about finding new ways to look at things. And this is a really recent push. And one way that we're accomplishing that is we're looking towards biology for inspiration. And there's a lot of different principles that you can extract from biological systems that can give you insight into how to make our own engineering systems more sustainable. Because nature, it's been around for a while, it gives you some good blueprints into how to make a system that can survive for a long time and doesn't have an adverse effect on the surrounding environment. So there are a bunch of different subjects that we're currently examining, and you can get information on networks, self-organization, things like traffic signaling and routing, energy limits for vehicles and different transportation modes. And it's all, I mean, it's a huge area. It's too much to go into here, but if anyone wants to find out more, we'd love to talk to you about it and get your thoughts, because it's really exciting. So after all of this assessment and examination, we can move forward to our other objectives of actually designing solutions and helping the situation. So from here on out, Sid will take that and tell you a little more about it.
All right. Thanks, Kyle. So Kyle said that part of our objectives at Georgia Tech is looking into technical options to improve urban mobility. So Ride Via, the project that I'm working on, is part of, it was the outcome of one of those processes.